Hey, good morning, guys. First off, just want to say thanks for all the work that you've been doing. Appreciate it. I know it's been some time consuming. It's been a lot, especially for those of us that aren't taking the test tomorrow. But I do appreciate it. Hopefully once we take it tomorrow, I think next week we'll kind of have a pretty calm week, and then we'll start to get into some different, hopefully fun and enjoyable different types of projects and stuff. So what I wanted to do was with the last assignment that I gave you out of the review book, that was an example of when you were taking a book test, five free response questions followed by a sixth one, which was a little bit longer, which I did not assign to you. I liked these five. I didn't want to give you too much work. I think they covered a good amount of topics, which hopefully you were able to feel pretty confident about at this point. I think with all the different practice and review, all the different resources on College Board, hopefully you've been utilizing your time uh, and you feel pretty good going into tomorrow. So let's just kind of go through each question, and then I want to kind of speak about some other things. But in this first question here, we were asked, are there any outliers? So try to answer the questions, fully. Make sure that you are being clear with things. So to find an outlier, by hand, it's the rule where we got to first find the IQR. So take the difference between Q3 and Q1, and then you're going to use Q3 plus the 1.5 times the IQR. At the same time, also do Q1 minus 1.5 times the IQR, and you're basically setting boundaries. Any observation that's above 15.1 or that's below negative 6.5, anything that's on the outside of those would in fact be an outlier. So the populations that were above the third quartile, anything above 15.1, so these four, the last four, all would be considered outliers in this data set. So there's nothing on the low end. All right. However, all populations greater than 15.1, which in this case 19.7, 19.9, 27, and 38.8, were all in fact outliers. All right. To make a box plot, you first want to make the box by making the three vertical lines. This would be the median right here, the Q1, the Q3, and the Q1. All right. Those vertical lines then turn out to make the box. Okay, you are then going to extend the lines on the outside to the minimum value. So this goes to the left to the minimum value. The line over here gets extended out, not to the maximum value, because the dots have to indicate outliers. So there's two dots there, a dot, and a dot. This line is extended to the highest value that is not an outlier. Make sure you label. Guys, if you have to graph, make sure you are labeling the scales, the y-axis, the horizontal axis. This one we didn't have to. It's already kind of labeled for us, but that's something that's often overlooked. All right, down here it says, at the time of the study, the estimated population of Missouri was 6.1 million. To what extent in terms of the population could it be described as a large state? Well, this is kind of just asking you to describe a measure of position here. So we don't, in the data set, we weren't given all 50 states. We know those that are less than Q1, so we know the bottom 25%. We know the top 25%. We don't have the middle 50%. We have the median and the quartiles, but we don't have all the values. So I first thought about trying to find a percentile, but it's not possible to locate exactly where Missouri would be compared to all 50 states. However, we do know that it is above the median. So it's definitely in the top half of the largest states. All right. However, it doesn't fall inside that top quartile, so it's not in the top 25%. So it's somewhere between, I guess you could say, the 50th and the 75th percentiles, right? It's somewhere in that category. It's bigger than half, but it's not in the upper 25. Okay, so this problem just gave us some information about spinning a spinner here, and tells you what would be in fact the win, depending on the score. So it says complete the table below by writing in each cell the amount won by each participant. So I did that. it then says probability. Remember, probability should be a decimal, should be a fraction. You just want to see, okay, amount 1, how many different ways were there to get 0? You don't have to reduce. It's up to you. So I did in this case, but that again would be up to you. And you want to be able to find expected value. Now, I've showed you 2 different ways to do that. You can make the list in spreadsheet. You could do it that way, right? And you would enter, and I'll take a minute to actually show you how to do that. So let's go over here. And in one column, I want to put my X values. And then right next to them in the next column, I got to put the probabilities. So 1/6, 7 out of 24, 1/4, 1/6, 1/12, and finally 1/24. All right. So here we have our amount win, our amount 1, and we also have the probability that each one of those events would occur. Okay, we're now going to do menu, statistics, calculations, 1 variable statistics. We have 1 list here, okay, and that list is in column A. What column B is our frequency list, all right? And most of the time, if you were doing something like this, like each event would occur once. But in this case, each one of them occurs a certain proportion of the time. So I'm going to put here, frequency is going to be in column B. And finally, I want to put my results in an empty column there in column C. So what this gives you, it gives you your expected value, your X bar, your average amount 1, which I'll show you in a second. The math on that wasn't too hard. The math on the standard deviation, though, is to me a little tedious. So if I was also asked to figure out that measure of spread, the standard deviation, I might have went to the calculator. You got to try to figure out what's going to be the most time efficient, all right, when it comes to the questions tomorrow. So there's our expected value. All right, now to me, explain how this value was calculated. I showed my work here. I took each X and I multiplied it by that specific X's probability. And it's the sum of those. And there it is, 1.83. This question was just kind of almost like an algebra question, I guess. You're kind of trying to solve an equation here. And you're told that he charges, or the stallholder charges $2.50 to play each game. You just found the expected amount 1 is $1.83, which means the difference would be 0.67 per play. All right, so if there was 400 plays, the stallholder would expect to make $268. And I would use words like that. If this is an expected value, and somewhere in my explanation, I would probably use that word expected. All right, question 3 here talks about how we would go about generating random samples. Okay, the hat method certainly might be the one we most feel confident with. This one here asked us to talk about how you can get it from a computer. So I just said, assuming the computer has a random number generator like our TI Nspire did, you would be able to generate a set of random integers between a certain set of values. In this case, from 1 to 439. You would first have to number all those hospitals. So, you'd have to give them a number, and then the numbers that you would get on the random number generator that would correspond to the numbers to the hospitals that you gave the number to, those would be the ones you would use in the sample. All right, remember that stratified, you're grouping by similar characteristics, right? And the whole purpose of that would be to limit those confounding variables. give yourself more control in the experiment or in the study. So if we formed strata, and we looked at each one of these as a strata, what that would allow us to do, if I wanted 40 hospitals, well, I want to make sure I have an equal amount of each. So I would make sure that I'd have 10 urban teaching schools, 10 urban non-teaching, 10 rural, 10 rural non-teaching. All right. It says explain why. Well, you could argue that the difference in cost of healthcare amongst both urban and rural and teaching and non-teaching hospitals, right? So again, you're trying to limit the variables, all right, so that you can better, I guess, give your explanations. You can better kind of give your inferences here and describe kind of what the problem's asking here as far as trying to figure out how expensive the healthcare is at the different state hospitals. All right. One thing that I attached for you today was an inference summary. And in that inference summary, you're going to notice how it gives you a lot of different things that I would utilize. It gives you the name of the test. It goes into giving you the conditions so you can make sure you can list those and coordinate all that. It talks about the name, like I said, the names of the test, whether it's for means or whether it's for proportions. So in this case here, we have students were randomly assigned to two groups. All right, they were Group A and Group B. These students were asked first given no music and then given music. And it says, do the results provide convincing evidence that students like the ones in the study, the true mean on task time when music is playing is greater than when there is no music? Okay, so you want to set up your hypotheses here. All right, make sure that you always define your parameters on the test tomorrow. Make sure that you say, well, what is mu sub d? Well, in this case, it's the true mean difference in on-task time, music minus no music. Because you could have went the other way. You could have said no music minus music. So you just have to make sure that you're defining the parameters that are being laid out for you. All right, check the conditions. Utilize the inference summary that, like I said, hopefully you see posted. It'll go through the conditions for you. No need to check the 10% condition here because it is an experiment. All right. Explain this normal large sample. You'll notice that I put the box plot on here. Right? On the test tomorrow, it's not going to be good enough just to say, well, the graph doesn't show. You have to show the graph, all right, unless it tells you not to. But you want to explain, well, the sample's not large enough, so we have to go and we have to graph the data. The data doesn't show strong skewness or outliers, so we can continue here. You don't have to go into detail about showing the equations to find p-value or anything like that. Show what buttons you hit in the calculator, utilizing the TI Inspires list and spreadsheet. Explain how you arrived at the p-value, and then give your conclusion. All right. Finally, in this last problem here with regression, these numbers here, the coefficient, that's going to be our x and our y, and our y-intercept here of our line. Read the problems thoroughly. It doesn't just say to determine the equation of the least squares regression line. Identify the variables. Well, x is temperature and y is the pH level. All right, and notice I put y hat because this is our predicted equation. And this one we had to find a residual. So the residual is going to be the difference of the observed and what was expected. So I knew what was expected when the temperature was 30 degrees. It was 7.08. I have to figure out what was predicted when it was 30 degrees. So I plugged 30 in for x, got 6.917, subtracted that from what was observed. The 0.163 is my residual. Again, read the question in its entirety. Not just find the residual, but explain the meaning of this in context of the study. All right. And then finally, this question, does the information the computer output provide convincing evidence? So what chapter, let me see here, I got my book out. chapter 12 in our book was more about regression. And it's basically allowed us to do inference for linear regression. So inference, whether it would be confidence intervals, whether it be significance tests. So that's what this one's kind of alluding to here. When you see convincing evidence, you know you should have to do a significance test. Here, we didn't have to do the entirety of the test because this computer output gives us the p-value, and that p-value is the 0.007. Now, like I said, this was the last chapter of our textbook, which also happens to be Unit 9. It also happens to be units that are not on the AP test. The units on there would be 1 through 7. So you don't have to necessarily worry about doing inference through regression. Okay. All right, guys. So hopefully this helped a little bit. What I would do today is go back and look at some of the print tests that I gave you that could be in Classroom. You could look at some of the answer keys that I gave you. Hopefully, you've kind of done this the last couple of weeks. Read what I posted in Classroom. I attached some links for you to look over. Make sure you have your test ticket number. Make sure you're familiar. And by this time, I think hopefully with us being a later test, some of you might already have some experience taking one. And if you didn't, and this is your first one, please ask me questions, reach out to me. But at the same time, you might also reach out to a friend or someone that I know that has taken 1 or 2 AP tests at this point, and just to kind of give you a level of comfort with what would be expected on the computer tomorrow. All right, so guys, good luck studying today. I'm going to keep posting some different messages in Classroom, and I'll talk to you soon.